Dr. Bharat Pankania is a senior clinical lecturer at University of Exeter Medical School. He joins us now from Bath in the UK. Thanks so much for being with us. How encouraged are you by these results?
I'm very encouraged, and it is a credit to all the scientists all over the world working on developing something which will help humanity. Having said that, I must utter a word of caution as well, because until the vaccine is delivered, it has not been delivered. So please, a word of caution, but I'm very optimistic that maybe on this occasion we will succeed with making a coronavirus vaccine.
So with that word of caution, I mean, what could still go wrong?
Well, nothing will go wrong, but the issue is coronavirus is a complex beast. And what we need is a vaccine that is able to trick the body into recognizing this virus when it comes to infect us and recognize it persistently, meaning over 3 months, over 6 months, over 9 months, over several years. That is a feat. That will be an amazing feat if we can trick the human body to recognize the coronavirus and then act against it.
Okay, so does the issue arise when there are potential, mutations, as is normal with viruses like these, because the same vaccine won't know to trigger the massive immune response with a mutated virus?
No, on that bit, I'm quite confident in saying I'm not worried about the mutations, because if we can make a vaccine against brand A, we can make a vaccine against brand B, brand C later on if need be. So I wouldn't be worried about the mutations at all. And to be honest with you, the infecting protein, the one that latches onto human cells to cause the infection, is often conserved. In fact, I would be so happy if there was a big mutation at that protein, which is the one that infects human cells, the ACE receptor protein, because then if it was mutated and it became ineffective, it would become an ineffective human virus. So that would be the virus dying out naturally. That doesn't look likely at the moment.
Okay, so the path it's on right now, tell me if I'm wrong, is it on the same kind of vaccine trail that really the normal flu virus is on, that we might have to adapt the vaccine every year, but generally, no? Explain.
No, not at all. And if I can take the opportunity to enlighten our viewers and listeners, it is this. The seasonal influenza virus changes its receptors. We call it the hemagglutinin and neuroimidase. Those are the two receptors against which we make the vaccine for the seasonal influenza, because they change every year. Whereas with the coronavirus, that receptor, the ACE receptor, ACE2 receptor, is conserved, meaning it is probably the same this year, next year, and the following year. So I'm not looking at making a different vaccine for a coronavirus if we are successful every year.
Okay. So if successful, I mean, how widely and quickly do you think this could be distributed?
Well, the signals from all the manufacturers are that they are taking the risk. They're taking the risk of building capacity, and that risk may prove fruitful, meaning they've made a vaccine, now they can go into full production. On the other hand, if the vaccine doesn't work, then all that capacity that they generated will be null and void. But it is a risk worth taking for the benefit of mankind, for all people all over the world.
Okay, Bharat Pankania, we'll leave it there. Thank you so much for being with us from Bath.